The P-51 had earned a fearsome reputation. It had appeared over Germany in late 1943 and changed everything. Before the Mustang, American bombers flew unescorted deep into Reich territory, and German fighters slaughtered them. But the Mustang could fly from England to Berlin and back over 1,000 miles round trip while fighting the entire way. It was faster than the Bf-109, more agile than the WWII, and it just kept coming. German pilots called it the Henker, the executioner. Hartmann had read the intelligence reports with professional skepticism. Every enemy aircraft was exaggerated by frightened pilots, but the numbers were undeniable. Luftwaffe losses had tripled since the Mustang's arrival. Experienced aces were falling from the sky. The Americans had achieved something Germany desperately needed: a long-range escort fighter that could dominate the skies. Now he would see how they did it. Hartmann walked slowly around the Mustang, notebook in hand. It was beautiful, he had to admit. Sleek, purposeful, with clean lines that spoke of aerodynamic efficiency. The aluminum skin was smooth, the riveting precise. No signs of manufacturing shortcuts or material substitutions. This was a quality aircraft, built right. He climbed onto the wing and peered into the cockpit. The instrumentation was comprehensive but not overly complex. Radio equipment was modern. The canopy provided exceptional visibility, a clear tactical advantage in dogfighting. Everything he saw confirmed what he already knew. This was a superb fighter aircraft, but it was the engine that would tell the real story. Hartmann and his two assistants began removing the engine cowling. It was a methodical process, bolt by bolt, panel by panel. As they worked, he calculated possibilities in his mind. The Mustang's performance suggested an engine producing at least 1,500 horsepower, possibly more. That meant either a massive radial engine like the American R2800, or a liquid-cooled inline engine like Germany's own DB605. Given the Mustang's slim fuselage, it had to be an inline. The cowling came away, and Hartmann found himself staring at the engine. His first reaction was confusion. The configuration was immediately familiar. A V12 liquid-cooled inline engine with a distinctive supercharger mounting. He had seen this exact design before. It looked almost identical to the Rolls-Royce Merlin, the engine that powered the British Spitfire. But that made no sense. Why would an American fighter use a British engine? He leaned closer, examining the casting marks and manufacturing stamps. His assistant stood beside him, equally puzzled. Klein pointed to the engine block. Herr Oberingenieur, look at this. Then Hartmann saw it stamped clearly on the engine block: Packard Motor Car Company, Detroit, Michigan, USA. For a long moment, Hartmann just stared at those words. His mind struggled to process what he was seeing. This was a Rolls-Royce Merlin engine, one of the finest aircraft engines ever designed, a masterpiece of British engineering. But it had been manufactured in America by an automobile company on the other side of the Atlantic Ocean. The implications hit him like a physical blow. He pulled out his reference materials and began cross-checking. The Rolls-Royce Merlin was a masterpiece, producing over 1,500 horsepower with exceptional reliability. It powered the Spitfire, the Hurricane, the Lancaster bomber. It was Britain's most valuable military asset. And somehow the British had given this technology to the Americans, who were now mass-producing it. The level of trust and cooperation this represented was staggering. Hartmann knew that Germany hoarded its technology jealously. The idea of sharing advanced engine designs with Italy or Japan was unthinkable. Each Axis power worked in isolation, protecting its secrets. But the Allies had done the opposite. They had taken Britain's best engine and handed it to America's industrial might. It was strategic thinking on a scale Germany couldn't comprehend. His assistants began a detailed examination of the engine, while Hartmann took notes. What they found was extraordinary. The Packard-built Merlin was not just a copy, it was an improvement. American manufacturing techniques had refined the British design. The tolerances were tighter, the materials more consistent, the quality control superior. Components were interchangeable between engines. Klein, who had worked on Daimler-Benz engines for 15 years, made an observation that chilled Hartmann to his core. Herr Oberingenieur, look at the manufacturing quality. Every cylinder is perfectly matched. This engine was built with unlimited access to high-grade aluminum steel alloys and precision tooling. They're not struggling to make these, they're making them easily. Hartman requested intelligence files on Packard and Merlin engine production. What he learned made him feel physically ill. Packard Motor Car Company, a luxury automobile manufacturer in Detroit, had been licensed by Rolls-Royce in 1940 to produce the Merlin engine. They had converted their automobile factories into aircraft engine plants. By 1944, Packard was producing over 2,000 Merlin engines per month, with plans to increase to 3,000. He did the mathematics in his notebook. 2,000 engines per month meant 2,4,000 per year. From a single company. Total Packard production would exceed 5,000. Merlin engines by war's end. For comparison, Daimler-Benz, Germany's premier aircraft engine manufacturer, was struggling to produce 2,000 engines per month total across all engine types. And German production was constantly disrupted by Allied bombing raids. But it got worse. The Merlin wasn't just used in the P-51 Mustang. It powered multiple Allied aircraft, the British Spitfire, Hurricane Lancaster, Bomber, and Mosquito. One engine design produced in 2 countries, powering dozens of aircraft types. It was standardization and cooperation on an industrial scale Germany couldn't match. Hartman examined the engine's construction in detail. The supercharger was a 2-stage, 2-speed unit that maintained power at high altitude. He found documentation showing maintenance schedules. Merlin engines were expected to run for 200 hours between major overhauls, sometimes more. German engines were increasingly failing after 100 hours or less as quality materials became scarce. The Americans were building engines that lasted twice as long, and they were building them in numbers Germany couldn't imagine. It was an industrial avalanche. As Hartman compiled his findings, he began to understand what he was really looking at. This wasn't just about one engine or one aircraft. It was about a strategic partnership between 2 industrial superpowers that had merged their capabilities. Britain provided the engineering excellence. America provided the manufacturing capacity. Together, they had created something Germany couldn't counter. The decision to license the Merlin to Packard had been made in 1940 when Britain stood alone against Germany. The British government, despite their traditional secrecy, had recognized that survival required American industrial help. They had handed over complete technical specifications, blueprints, metallurgical formulas, everything. It was an act of strategic trust that Germany would never have made. Packard had then done something remarkable. They had converted the British measurements from imperial to metric redesigned components for American mass production techniques and improved the manufacturing process. They had taken a hand-built British engine and turned it into a mass-produced American product without losing quality. In fact, they had improved it. Hartman thought about Germany's relationship with its Axis partners. Each nation fought its own separate war with its own isolated industry. The Allies had created a unified industrial war machine spanning 2 continents and multiple oceans. The implications for the Mustang's performance were clear. The Packard Merlin gave the P-51 the power and altitude performance it needed. Combined with the Mustang's exceptional airframe design and large fuel capacity, it created a fighter with over 1,000 miles of combat radius. No German fighter could match that. Hartman requested additional intelligence data on P-51 production. The numbers were soul-crushing. North American Aviation was producing P-51 Mustangs at a rate of over 500 aircraft per month by late 1944. Total P-51 production would exceed 15,000 aircraft. Combined with the thousands of Spitfires and other Merlin-powered aircraft, the Allies were deploying tens of thousands of fighters powered by this single-engine design. Germany's entire single-engine fighter production for 1,944 would be approximately 2,500 aircraft total across all types. But German production was constantly disrupted. Allied bombing raids destroyed factories faster than they could be rebuilt. Material shortages forced compromises in quality. The Packard Merlin production, by contrast, was untouched by war. The factories in Detroit operated 24 hours a day, 3 shifts, 7 days a week. raw materials flowed in unlimited quantities. Skilled workers, including thousands of women, operated precision machinery. Hartman calculated the engine production ratios. By 1944, Packard alone was producing more Merlin engines than Germany produced total aircraft engines across all manufacturers. The Allies were winning an industrial war through partnership. Germany was losing it through pride. The result was undeniable. Germany, with its ideology of racial superiority and distrust of allies, had chosen isolation. The Allies, through trust and cooperation, were burying them in aircraft. Hartman's final report was 47 pages long. It documented the Packard Merlin's technical specifications, manufacturing quality, and strategic implications. His conclusion was devastating. The P-51 Mustang, powered by the American-built Packard Merlin engine, represents a synthesis of British engineering excellence and American industrial capacity. The strategic implications are profound. The Allies have created an integrated industrial war machine that Germany cannot match. The report was sent to Luftwaffe headquarters in Berlin. Hartman waited for a response. Days passed, then weeks. Finally, he received a brief message from a staff officer. Report received and filed. Recommendations noted. Continue current assessment procedures. That was all. Through informal channels, Hartman heard the real response. His report had been read by several senior officers who had reacted with anger rather than concern. One general had reportedly said, "This engineer has been demoralized by examining enemy equipment. Our jet fighters will sweep them from the skies." The assessment was filed away and forgotten. Hartman wasn't surprised. He had seen this pattern before. Intelligence that contradicted Nazi ideology was rejected regardless of accuracy. The leadership didn't want analysis. They wanted validation of what they already believed. When reality contradicted the fantasy of German superiority, reality was dismissed as defeatist propaganda. Silence was safer than honesty. In the months following his report, Hartman watched his predictions come true with painful precision. P-51 Mustangs appeared over Germany in increasing numbers. German fighter losses mounted catastrophically. Experienced pilots, the irreplaceable aces, were shot down and not replaced. Replacement pilots arrived with minimal training and died within weeks. The Luftwaffe's tactical adjustments came too late. The industrial advantage was too great. For every German jet produced, America built 100 Mustangs. The statistics became overwhelming. Total Packard Merlin production exceeded 5,000 engines. Total P-51 Mustang production exceeded 1,500 aircraft. The combined Anglo-American production total was over 4,300 military aircraft. German production for the same period was approximately 9,400 combat aircraft. The Allies had produced more than 4 times as many planes. After the war, the world fell silent, and Franz Hartman found himself in a sterile room facing the very men who had built the machine that had haunted his thoughts. American technical intelligence officers had one question for him, a question that cut to the heart of his discovery. Did you really conclude from examining one engine that Germany would lose the war? Hartman's answer was not that of a defeated soldier, but of an engineer who had seen the undeniable truth in the numbers. "I concluded," he said, "that Germany could not win an industrial war against an Anglo-American partnership. The Packard Merlin was evidence of strategic cooperation on a scale we couldn't imagine. But the final soul-crushing validation was yet to come." The American officer, with a sense of grim respect, showed Hartman the final production statistics. Hartman's report had been devastating, but the reality was an avalanche he hadn't even fully conceived. "You actually underestimated our capacity," the American said. The total combined production of the Merlin engine family from both Britain and America exceeded 2,000,000 units. A number so vast, so utterly overwhelming, it confirmed that Germany was never just fighting an army. It was fighting an entire continent's industrial soul. When asked why the Allied partnership had been so devastatingly effective, Hartman's answer was not about horsepower or aerodynamics. It was about something far more profound. Because it was built on trust, he stated. Britain trusted America with their best technology. America trusted Britain's engineering expertise. That trust created cooperation that multiplied both nations' strengths. Germany trusted no one. And so, we fought alone. Trust won the war. In the end, the legend of the P-51 Mustang wasn't just written in the sky with smoke and fire. It was forged in the heat of foundries in Detroit and design offices in Derby. It was a testament that an alliance built on shared values and mutual trust could unleash a power that no single nation, driven by pride and isolation, could ever hope to match. The Mustang wasn't just a machine. It was a promise kept by two nations and delivered at 400 miles per hour. What do you believe was the single greatest factor in the Allied victory? Was it this industrial partnership, a specific technology, or the spirit of the soldiers themselves? Let us know your thoughts in the comments below. If this story has given you a new perspective on history, do us a favor and hit that like button. Subscribe to our channel for more incredible stories that the history books often forget, and share this with anyone who needs to understand the Bentis, true engine of victory. Thank you for watching. In war, the deadliest weapon isn't always a bomb or a bullet. Sometimes it's a piece of paper, a simple agreement. In the chilling autumn of October 1944 deep, inside the failing heart of Nazi Germany, one of the Reich's most brilliant engineers was about to discover this truth in the most terrifying way imaginable. His name was Franz Hartmann. He wasn't a soldier. He was an Oberingenieur, a man who believed in the pure, cold logic of numbers and the undeniable truths of physics. His world was one of compression ratios, horsepower, and aerodynamic efficiency. Politics was just noise. Ideology was an irritation. At the secret Recklen Test Center in Bavaria, his job was simple: dissect captured Allied aircraft, find their weaknesses, and give the Luftwaffe a fighting chance. He had seen them all: Spitfires, Thunderbolts, B-17 bombers. Each one held secrets, some of them disturbing. But nothing, absolutely nothing, could have prepared him for the machine. Now, sitting silently in his hangar, a North American P-51 Mustang, the silver demon that haunted the skies all the way to Berlin. This fighter possessed an impossible range and a lethal agility that was systematically dismantling the once invincible Luftwaffe. The high command was screaming for answers. Hartmann was there to provide them. He approached the captured fighter with his tools and notebooks, expecting to find a superior engine, perhaps a clever new supercharger design. But as he and his team began to peel back the smooth aluminum skin, he had no idea he was about to uncover something far more profound than an enemy aircraft. He was about to find undeniable proof stamped into cold hard steel that the war was already lost. Not on the battlefields of Russia or the beaches of France, but in the roaring factories of two Allied nations working as one unstoppable industrial superpower. The secret he found inside that engine would unravel everything he thought he knew about warfare. It's a story of how trust, not terror, became the ultimate weapon. If you are fascinated by the hidden stories that truly decide history, make sure you hit that subscribe button, because you will not want to miss what happens next.